Alrighty, so this video is on, it's kind of a short little review. It is from last year's unit recovery, which is all of the questions that last year students had the most trouble with on the test. So we're going to work through, I don't even know, is it five? Yep, 5 problems here. And this is just kind of help you guys out as you prepare for the test. So, first one, find the measure of the numbered angle, show all work, and box your answers. So, first thing to notice here is that I'm looking for an angle that intersects or is formed by two secants intersecting outside the circle. So if we remember, on the outside it's 1/2 times the difference of the two intercepted arcs. And when I say intercepted arcs, I'm talking this one and this one. Okay, so first goal should be to take 360 minus 101 minus 107 minus 105, because that will give me this angle right here. Or not that angle, sorry, that arc, because 360 is that entire thing, so that's going to be 47. So I can say that angle 1 is equal to 1/2 times the difference of the two, 107 minus 47. And if we do that, 107 minus 47 gives you 60. Half of that is 30, so angle 1 would be 30 degrees. Okay, next one, we've got a diagram here where we've got to piece a lot of different stuff together. So, first thing is that I know AD is a diameter. I know the measure of arc DF. So DF, I'm going to highlight that from D to F. That is 135. And measure of angle BCA, so B to C to A, that is 26 degrees. Okay. So first thing to look at here is, what are we trying to find? The measure of angle 1. So this is what I want to know. Measure of angle 1. Now, what we can think about is this angle right here is a central angle, and I know that that entire thing is 135 degrees. Since it's a central angle, it is the same as the intercepted arc. So I know that's 135. Now notice this is my diameter, so I know that's a semicircle. So I know that that's got to add up to 180. So I can take 180 minus 135 to tell me that the measure of angle 1 is 45 degrees. Okay, so I'm going to erase some stuff here, and I'm going to be doing this a lot throughout. Measure of angle 1 is, let me zoom in as much as I can, 45 degrees. Okay, next thing to do is to find the measure of angle 2. The first thing that I notice is if you look at that, and I will use this color. If I look at angle 2, it is formed right there. It is an inscribed angle. And I know that entire intercepted arc is the one that I have drawn in red there is 135. So in order to find the measure of angle 2, the inscribed angle is half of the intercepted arc. So I can go 1/2 times 135, which gives me 67.5 degrees. Okay, so angle 2 is 67.5. Now, nice thing here is right off the bat, to find angle number 3, I've got 2 angles in a triangle, so I can go 180 minus 45 minus 67.5. If we do all of that, it turns out that that is the same thing, 67.5 degrees. Okay, so I'm going to erase that. This one down here is 67.5 degrees. This one was 45, I think, right? Yep. Okay, the measure of angle 4. So to find the measure of angle 4, one thing that I notice here is measure of angle 4. It's an inscribed angle. It is hitting over here at one point. It doesn't continue out this way, so I can't look at half of my arc there. But what can I do here? Let me back up on that. So I know that that measure of angle 4, let me think here. I know it's 22.5. How did I get that? Okay, I know this whole thing was what, 135? I know that we could think of this a couple of different ways. So if this is 45 degrees right here, let's just go through. This isn't how I did it the first time, but this might work. Okay, this is an inscribed angle, so I know that arc is 45. And if I look here, that this would then be 45. That doesn't help me though, does it? How do I get, oh, here we go. Oh, okay, back up. This is the key here. Took me a second to see it. So look at angle 3 and angle 4 together. I'm going to erase this. Angle 3 and angle 4 together is an inscribed angle, and notice that it's hitting that diameter, that semicircle. So I know that this has got to be 90 degrees altogether. So then what I can say is that angle 3 plus angle 4 have to be equal to 90. So angle 4 is going to be 90 minus 67.5 degrees, which gives me 22.5. Okay, because it intersects that diameter. Okay. I had to think a little bit on that one. All right, angle 5. So angle 5, if I look, is back to, I think we probably learned it in the inscribed angles, because angle 5 is inscribed. So if I go from here to here and I look at my intercepted arc, one thing to notice is that if I draw it in red, it's intercepting the exact same arc as this one right here. So since they're intercepting the same arc, they're going to have the same measure. So since it's inscribed, if that is 26, that would mean that the arc measure is going to be double that. So 26 times 2, that's going to tell me that this entire arc is 52, which tells me that this, oops, is also 26. Now, we had a theorem that told us that this angle and this angle would have to be congruent if they intercept the same arc. So really, you wouldn't have had to put that 52 on there. The only reason I'm doing that is because on the next part, and I'm getting pretty messy here, so I'm going to erase a whole bunch of this, is the next part is asking you to find the measure of arc BD. Okay, now arc BD is going to be the minor arc from there to there, and notice that BD plus BA would have to get us to 180 because it's a semicircle. That's why I put that 52 in there right away, because I can go 180 minus 52, which gives me 128 degrees. Okay. Our next one, we've got solve for x. So notice that this is an inscribed angle. That inscribed angle is going to be half of the measure of this arc. I can find the measure of that arc by doing 360 minus 62. Nope, not minus 62, 162 minus 92. Let me do that real quick. 360 minus 162 minus 92 is going to give us 106. Okay, so this in orange is 106 degrees. So I can say that 7x minus 10, why did I write E? 7x minus 10 has to be equal to 1/2 times whatever that angle is, 106. That gives me 7x minus 10 is equal to 53. 7x is equal to 63. And we end up with x is equal to 9. And we just had to find x, so we are done there. Okay, so that was an inscribed angle. Notice this next one is formed by intersecting outside the circle. So if you remember, that is where you take half of your difference of the intercepted arcs. So notice that I've got this one is 81. I've got to do from here to here, I've got to figure out what that is. Now again, we can do that by 360 minus 81 minus 74, which is going to tell me that this arc right here is 205 degrees in red. Okay, so that angle, 17x minus 23, would be equal to 1/2 of the difference between your larger and smaller arc that are intercepted. So 205 minus 81. This is going to give me 17x minus 23 is equal to If you do 205 minus 81, that gives you 124. But I've still got to multiply that by a half, so I'm going to go 17x minus 23 is equal to half of 124 is equal to 62. Okay, add 23 to both sides, so I'm going to go 17x is equal to, that would give us 85. All of that work then tells me that x is equal to 5. That's all I had to find, so we are good to go. Okay, last one. The measure of arc BD, BD from here to here is 20 degrees. And the measure of angle AOD, so A to O to D, right there, is 4x minus 32. So 4x minus 32. Now, notice that this is my center of my circle. So this is a central angle. Since it's a central angle, it's the same as its arc measure. And notice that when you look at these two together, they form a linear pair. They got to add up to 180. So all I have to do here is go 20 plus 4x minus 32. Since it's a semicircle, it's got to be equal to 180. Okay, so 20 minus 32 would give me 4x minus 12 is equal to 180. If I add 12 there, I get 4x is equal to 192. Divide by 4, x is going to be equal to 48. Okay, so this doesn't cover everything on your test, but again, this is some of the most commonly missed topics from what geometry students had last year.